Okay, so let's go ahead and take a look at this lesson. So this one is talking about where a function is concave down. So I'm going to take the derivative, and then I'm going to take a second derivative. So let's make some room here. Okay. X minus 3 times negative 1 minus x times 1 over x minus 3, the quantity squared. So y prime x minus 3, and it's a negative and a plus. Distribute my negatives, so a minus 1 and a plus x, all over x minus 3, the quantity squared. So y prime is 2 over x minus 3, the quantity squared. So now what I can do is I can go ahead and take a second derivative. So I have, I would change this probably to 2 times x minus 3 to the negative second power. So that gives me a 2 times negative 2 x to the x minus 3 to the negative third power times 1. So y double prime is negative 4 over x minus 3, the quantity cubed. And now remember, possible points of inflection or critical numbers can be where the denominator is equal to 0, so where the derivative does not exist. So that is x is equal to 3. And this is a multiple choice, so I can use just like a number line, and I'm plugging in 0 and I'm plugging in 4. And so I'm doing that into the derivative, and I get positive here and negative here. So it is concave down, or sorry, concave up, less than 3 here. Okay. Here, points of inflection again. So f prime of x is equal to 1/2 11 plus x squared to the negative 1/2 times 2x. So f prime of x is equal to, those cancel out, so I'm left with x over root 11 plus x squared. So then I'm going to take a second derivative to find a possible point of inflection. So low d high minus high, d low all over the denominator squared. So essentially what I get is f double prime is 11 plus x squared to the 1/2 minus x squared, because the 2's cancel out, and I'm left with 11 plus x squared to the negative 1/2 all over 11 plus x squared. So I can factor out, remember how we did that weird factoring, 11 plus x squared to the negative 1/2. I'm left with an 11 plus x squared to the first power minus x squared all over 11 plus x squared. So now f double prime of x is 11 plus x squared to the negative 1/2. And I'm left with an 11 and a 11 plus x squared to the first power. So when I set this equal to 0 to solve, essentially what's going to happen is, let's be clear, these are the same terms here. So I can rewrite this as 11 over 11 plus x squared to the 3/2 power. So then I set that equal to 0, so x is equal to plus or minus the square root of 11. And so I have a negative square root of 11 and a positive square root of 11. I have 0 in between. Square root of 11, so 4 and negative 4 here. So when I plug in my 0, I will get a positive. When I plug in negative 4, I'm also going to get a positive, and I'll get a positive here. So there is no point of inflection. Okay? Question 5. So I am looking for what might be true. So let me take a derivative. So f prime of x is equal to x cubed minus 4x. And then I need to take an x out. So 0 is equal to x squared minus 4. So x is equal to plus or minus 2 and 0. When I do my number line here, -2, 0, and 2. What I'm going to get is, let's see. I should factor this out a little bit better. So 0 is equal to x minus 2, x plus 2. So I plug in -1. This will be a positive 1. That'll be a 3 and a -3. So get negative. I think this was supposed to be which one is. I think this was supposed to be which one is false. Okay, so here I'm going to get positive. Here I'm going to get a negative, and here I'm going to get a positive. So it does actually have a relative min and a relative max. I think this was supposed to be false. So when I take a second derivative, let's see what happens. F double prime of x is equal to, 3x squared minus 4. And it is actually E. And the reason why I say it's E is because F is concave downward, means that it's downward on the entire interval. So this would have given me 0 is equal to 3x squared minus 4. So 4 is equal to 3x squared. So x squared is equal to x squared is equal to 3/4. So x is equal to plus or minus √3/4. So you will get negative, positive. When I plug in 0 in here, I'll get a negative, and it'll be positive and positive on each side. So essentially, in this case, what I will do is I will have, it's not concave downward on the entire interval, which is why that's, it should have been false, not true. Okay. Inflection points. So y prime is equal to 20x cubed minus 5x to the 4th. I'm going to take a second derivative. So y double prime is equal to 60x squared minus 20x cubed. So I can factor out a 20x squared, and I'm left with 3 minus x. So then x is equal to 0 and 3. Possible points of inflection. So here's 0, here's 3, 1, -1, and 4. So at 1, -1, it'll be a positive, and a negative. So there's only a point of inflection at x is equal to 3. Okay? And that is it for this section.